session.
Thanks, Rainer. Yeah. So, hi everyone. Welcome to today's webinar. We're going to cover Tanzu Kubernetes Grid. So, just introductions first of all. My name is Mark Nagel. I'm a technical director within Tanzu Product Support, based out of Cork in Ireland, working for VMware since like almost 3 years now. Previously worked in Pivotal, previously worked in EMC and Dell EMC. So my current role is I have a global role. It's a support product manager of the Kubernetes platform domain within Tanzu Support, responsible for the product feedback with R&D, product lifecycle, escalation, team enablement, that kind of stuff. So I guess I'm in a customer-facing role the last 15 years. So I'll pass it over to Peter now.
Hi everyone. Peter Ryan is my name, and I work on the same team as Mark. I'm also based in Cork here in Ireland, and I've been working with VMware just over 3 years, and previously I've worked with Pivotal, and prior to that I worked with a lot of telco customers, telco operators, integrating our telco solution into different operators around the world. And so I've been mainly working on the Tanzu Kubernetes products over the last couple of years, dealing with customers and working with escalations on with the support team. Okay, thank you.
Thanks, Peter. So what I do now is we'll go into the agenda, but just before I go into the agenda, I want to make sure people are aware what Tanzu is within VMware. So the short answer is Tanzu is not a single product, it's a portfolio of products that enable enterprises to modernize both their applications and their infrastructure. And currently some of the products within the Tanzu portfolio are Tanzu Kubernetes Grid that we'll go through today. There's Tanzu Mission Control, vSphere with Tanzu, Tanzu Observability, Tanzu Service Mesh, Tanzu Application Platform, and Tanzu Application Service. So there's quite a wide variety of products under the Tanzu portfolio. So I'll get started with the agenda. So can you all see the slide? Yeah, cool. So I'm going to introduce Tanzu Kubernetes Grid. Okay, but first of all, I want to introduce you to a few of the Kubernetes open source projects that are part of Kubernetes and that are used within Tanzu Kubernetes Grid. And then Peter will go through a day one operation, so he'll go through an install and configuration of TKG and basically go through some troubleshooting steps and walk you through the flow. And then we look at some day two operations. So we're going to concentrate on certificate management because from a support perspective, it's always an area we get a lot of issues on. And then we'll also look at our Crashd diagnostic tool, which helps capture all the logs necessary to troubleshoot the product offline. Okay, so I'll go ahead and get started. So the first part, we're going to look at Kubernetes itself, okay, and kubeadm particularly. So Kubernetes, also known as K8s, is an open source system for automating deployment, scaling, and management of containered applications, okay. So it's a container orchestration. In summer of 2015, Kubernetes 1.0 arrived, but with one huge user experience problem. Okay, it was difficult to install. Lots of DIY Kubernetes being built by individual companies. And if you're interested in actually how hard it was to install it, there's a very good GitHub page called Kubernetes the Hard Way by Kelsey Hightower. It goes through what's needed to get a Kubernetes system up and running in a very manual way. It covers creating your own compute VMs, bootstrapping your own etcd cluster, supplying your own certificate authority and signing your own TLS or generating your own TLS certificates for all the individual components that need to interact within Kubernetes. So quite a lot in there. So fast forward to December 2018 and the kubeadm project became GA. So kubeadm is a tool that enables Kubernetes administrators to quickly and easily bootstrap a minimum viable cluster that is fully compliant or conformant, as we call it. It was developed by the Special Interest Groups Cluster Lifecycle team within the Kubernetes community. So it's referenced to SIG, Cluster Lifecycle. So this product helped bootstrap a cluster. So it took all of the manual effort that was needed, and it kind of simplified that and gave us an easier way of installing a viable Kubernetes cluster. So it solved the installation issue and the complexity around installation and made it easier to install Kubernetes, but it did not address how to manage the cluster on a day-to-day basis, or it didn't help us manage the Kubernetes environment long term. So one example is what happens when a node fails. So if a node failed, you would have to manually create a new compute VM or whatever your machine was, install all the packages on it, configure it, install the certificates, join it to the cluster, and then delete the old VM if it was unrecoverable. And we had the same scenario with scaling or upgrading. It was a very manual, hands-on experience for the operator. And it held back Kubernetes, I guess, from being enterprise ready. So then fast forward to, I would say, like October of last year, we got a Cluster API, which is a new project that became production ready. So again, the special interest groups cluster lifecycle began this Cluster API project as a way to address the gaps by building a declarative Kubernetes-style APIs that automate cluster creation, configuration, and management. Now, the key word here is cluster-style APIs. So basically, we would need a Kubernetes cluster to create a Kubernetes cluster. Hence, the logo shows. Yeah, can you hear me now? Yeah, and see me? Yeah.
Yep. You're back.
Okay, great. Yeah, so using this model, Cluster API can also be extended to support any infrastructure provider, AWS, Azure, vSphere, or Bootstrap provider you need. And so the default Bootstrap provider is kubeadm. We already discussed what that does. So features of Cluster API that were released as of V0.3, which was the V Alpha 3 API in March, included things like automated replacement of unhealthy nodes. So that manual effort that I described when I was looking at the kubeadm section was no longer needed. We also had a declarative way of creating our control plane within the cluster using the kubeadm control plane object that was introduced. So we could now configure our control plane, make changes to it, and manage it, manage the life cycle of it within our cluster. So I'll go into the concepts now of Cluster API and how it works. So I guess given that we Cluster API uses Kubernetes style APIs, right? And the concept is to manage Kubernetes clusters, there must be a management cluster. Okay, we need somewhere to host the CAPI or the Cluster API. So basically we need to establish a management cluster. Okay, and you can see it referenced here on the top left. But one of the ways that we go about creating, or how it's known within the community, how you create a management cluster is called like Bootstrap and Pivot. And I'll give you a high level description of that. So like you create a temporary Bootstrap cluster. It can be a very small cluster like a Kind cluster or Minikube, whatever it might be. And then you can make that Bootstrap cluster into a temporary workload or management cluster. Management cluster, and you can apply the Cluster API to that cluster then using clusterctl commands. You can use Cluster API then, but we use that temporary management cluster to establish a workload cluster. We use the Cluster API to create a workload cluster, which is more of a highly available cluster on our infrastructure of choice. And then we can convert that workload cluster into the permanent management cluster, and then we will have to pivot or migrate or move the CAPI or CRDs created on the Bootstrap cluster to that permanent management cluster. And then we can remove the Bootstrap cluster. So those are the sequence of events that have to happen to kind of create a management cluster, because it's like Kubernetes on Kubernetes, we have to start somewhere. But regarding Cluster API itself, you have to be familiar with the concept of controllers. And controllers are the core of Kubernetes. or of any operator. It's the controller's job to ensure that any given object, that the actual state meets the desired state, so that when you create your YAML file and you use kubectl to apply it, it gets put into etcd, and that's the desired state. So the controller will look at the object and make sure that the actual state of the object meets the desired state, and it's constantly reconciling to make sure that they match up. And then we have the concept of custom resource definition. So if you like, there's objects exist in Kubernetes like pods, nodes, all that stuff, but you can actually create your own kind objects, and it's called extending Kubernetes API. So you can create custom resource definitions that basically extend Kubernetes API to whatever objects you need to create. Like Cluster API uses machine deployment, machine sets, and machine health checks. These are all custom resource definitions that will be used by Cluster API. And then quickly on the right hand side here, you can see cluster is basically, we create the YAML for the cluster and we apply it and creates our cluster object. And within the cluster object, you have an infrastructure cluster, which is like vSphere, AWS, Azure, whatever is needed for that infrastructure resources to get applied. Like in AWS, you might have regions. In vSphere, you'll have failure domains. And then we have the control plane, and that's simply the control plane object that manages the control plane. So we have the kubeadm control plane objects that configure etcd and get it up and running and have all the certs and all that stuff in there. And then we have like the machine, and the machine is a one-for-one matchup with a worker or a control plane node. So like you can have the Bootstrap config, which says how to bootstrap it. For example, kubeadm, tell kubeadm how to run the pre-kubeadm commands to set up and create the packages and stuff on it, and add the certs in and stuff. And then post kubeadm to verify that it's been done. And then we have machine deployments. First we have machine sets. So a machine set is like a replica set. It has a group of machines in it. So we'll say we have 3 machines. It will make sure that we continue to have 3 machines. So if one becomes unhealthy, it'll remove it and add in a new one. And then we have machine deployment, which it looks after the machine sets. And if you want to change something within the machine deployment, it will roll the machines that are in that deployment and make the change. So at the bottom you can see that we can run it on AWS, Azure, Google Cloud, VMware. So the Cluster API gives us the ability to provision a workload cluster on any of these infrastructures providers. So that's roughly what Cluster API does under the hood. And I'll just move on now because I'm cognizant of time. So Tanzu Kubernetes Grid is a high-level name for the upstream compatible Kubernetes runtime from VMware. It's also formerly known as TKG. Okay, it's a multi-cloud Kubernetes footprint that you can run both on-premise or in vSphere, in the public cloud or on Amazon EC2 or on Microsoft Azure. So if you have management cluster, you have the ability to provision a workload cluster on Amazon, Azure, or vSphere at the moment. In addition to Kubernetes binaries that are tested, signed, and supported by VMware, TKG includes signed and supported versions of open source applications to provide registry, networking, monitoring, authentication, ingress controller, and logging services. Everything you need to run Kubernetes in production. So basically that's the introduction to TKG. It utilizes kubeadm and Cluster API in the back end. And I will now pass you over to Peter.
Hi everyone. So what I'm going to do here now is I'm going to go through the installation of TKG, the creation of the management cluster and the workload cluster, and then I go through some of the troubleshooting steps that for troubleshooting the Bootstrap and the management, and then I'll go through a quick demo covering the installation of TKG. So as Mark was mentioning earlier, with Cluster API, one cluster is basically used to manage other clusters. So a management cluster will be used to manage the workload clusters. But we need to create the management cluster. So what we do is we spin up a temporary Bootstrap cluster, and we'll use this then to create our management cluster. Tanzu has a CLI then, and that's what we use to actually to create our management cluster. So to create our management cluster, then we just we use Tanzu CLI and a configuration file. In this example here, it's cluster.yaml, and it has some information around the spec of the management cluster and details for the VMware registry, and also details of your IaaS. So in the example I'll cover here, it'll be vSphere. So when you kick off your Tanzu management cluster create, it initially does some validation of your data in your cluster.yaml, and then it creates a Docker container for spinning up a kind cluster. So some of you may be familiar with that. Kind is Kubernetes in Docker. So it just basically runs Kubernetes within a Docker image. So it spins up Docker, and then it retrieves any of the necessary images from VMware registry, and creates the Kubernetes node. Then retrieves the kube config, and then it installs the cluster API controllers and providers that Mark had mentioned earlier. Okay. So once we have our Bootstrap cluster, then this is used to create our management cluster. And so essentially what's happening underneath the hood then is like it's the equivalent of a kubectl apply on the Bootstrap cluster using data from the original cluster.yaml file we provided. So we create different resources, the cluster API resources on the Bootstrap cluster, namely the likes of cluster, KCP machines, machine deployment, and machine health check. And then this triggers the creation of the VMs on your vSphere or whatever IaaS you're using. And then Kubernetes is bootstrapped on those nodes using, and the configuration is run as part of a cloud init script. And likewise then with the creation of the Bootstrap cluster, we reach out to VMware registry and retrieve whatever images are needed, and say for like the core components, CNI, CPI, and so on. And the same as the management cluster, we retrieve our kube config then and install our cluster API components. So once your cluster API components installed, then you've a TKG managed cluster. So one last operation that Mark had mentioned earlier as well is that up until this point, like we have a Bootstrap cluster and a management cluster, but the cluster API objects for that management cluster reside on the Bootstrap cluster, but we need to move those onto the management cluster. And once that is completed, then the management cluster is managing itself, and with no further requirement for the Bootstrap cluster, and it is terminated. So at this point, then you have, you're in a position where you can proceed and create any workload clusters that you want. So creation of the workload cluster is, again, we use the Tanzu CLI, and you provide a simple cluster YAML file. The configuration is much less in this. It's really just the cluster name and kube API IP address, and that's really all the information that needs to be provided. And you run this, it creates our workload cluster, creates our VMs on our IaaS, reaches out to the VMware registry, and bootstraps the cluster on the VMs. And once that's completed, then you can use a Tanzu CLI to retrieve your kube config for your different clusters. So then I just want to cover some of the bootstrapping, or sorry, some of the troubleshooting steps that we can perform if you do encounter issues during the various stages. So the first one is to troubleshoot the Bootstrap cluster. And as I mentioned earlier, this is the Bootstrap cluster is a Docker image or a kind cluster. So you're just using Docker CLI to check the status of the container, and then Docker exec to log into that particular container and check the status of the Kubernetes components. And that's using containerd. So we use CRI-CTL to view the status of the pods and check their logs. And so that's kind of if the kube config hasn't been created, and if it has been created, then all your core Kubernetes components are up and running, and kube config will be generated in a predefined directory, and we can use kubectl then to view the status of the pods and check for any issues. Then for troubleshooting the management cluster, if the kube config will be generated and stored in the default location of .kube and config file, and we use kubectl then to view the status of the pods and the logs. But if there are any issues with that, then we'd SSH to the control plane nodes, and containerd is used again, and use CRI-CTL to troubleshoot the pods and the containers. And if there are issues beyond that then as well, we check the status of the containerd and kubelet. These are run as Linux services on the VMs, and use standard systemctl and journal CTL then to view the status of those logs. And the actual bootstrapping of the cluster itself is run as cloud init, and we can view the cloud init log files there. I'll cover that in the demo later on then as well. And cluster API logs, we can view the cluster API logs on the Bootstrap cluster, and then any events or alarms on vCenter AWS. So yeah, so I'm just going to do a demo now of the actual installation. So just give me one moment. Okay, so what I'm doing here is just going through the creation of the management cluster, and you can see the first step, it just kicks off the bootstrapping, the creation of the Bootstrap cluster. And can you see it at the bottom?
Yeah, no,
Sorry, just 1 second now. Okay, so it's after creating the Bootstrap, the kind cluster, and I logged into it, and I'm just running CRI-CTL then to view the status of the containers on our Bootstrap. And you can see here now that has actually generated the kube config. So I just set the kube config, and then we'll be able to use that then to run kubectl to check the status of the pods on our Bootstrap cluster. Yeah, so then you can see all the various different pods in our, the standard core Kubernetes ones. And at this stage, then it would have created the machines for our management cluster. So this is one of the cluster API resources, and we can also view the cluster API components there, and we can check the CAP-V cluster API component and view the status of the machine creation on our on vCenter. So you'll see it goes through the various different phases here, where it's cloning the VM, configuring the VM, and then powering it on. So if there's any issues, then that's the sort of log that you would need to look at. So after a few minutes, then the machines would be provisioned, and our cluster would be created then as well. So and you can see up on the top screen then as well that it has generated the kube config in the default directory. So we can set our kube config to that to point to that file, and we can view the status of our Kubernetes components. So just setting the context here now, and then we check the status of the pods on the cluster. So you can see it has installed the core Kubernetes ones, like your etcd, controller manager, API server, and scheduler, and some of the additional ones were just in a pending state. So after a few minutes, then we can see that it does complete the installation of those, and just checking the cluster API specific pods. You can see that they are all up and running now. And as I mentioned earlier then as well, if you do encounter issues, then you can SSH to the likes of the control plane node, and then you can use CRI-CTL, check the status of the pods, and you can also use that as well to check the logs for any of those containers. I'm just checking etcd here now at the moment. That was obviously one of the first ones that would start. Containerd and kubelet as well, as I mentioned, they are run as Linux services, so we check the status of both of those two, and we can also use journal CTL then to view the logs for those two components. And the other thing as well is to troubleshoot the bootstrapping of the Kubernetes node itself. We view the cloud init log. So within that cloud init log, then you will see the likes of the kubeadm command that Mark had mentioned earlier, and we're looking then just to verify that the cluster has been bootstrapped successfully. So that kind of covers the main troubleshooting that you would do on the VM itself. So up at the top, then you can see that we're actually, the cluster management cluster has been created, and then we're moving all the objects from the Bootstrap cluster to the management cluster. and then we can check the status of our management cluster now, and we can see where our management cluster is created, and we can see all the different components and the cluster API components installed on the cluster as well. And we can check the status of some of those cluster API objects as well. We can see this is just a 2-node cluster, one management or one control plane node, one worker node. You see the cluster API object, all the machines that have been that are associated with those 2 nodes, and also the kubeadm control plane object as well, and the machine deployments and the machine health check. So they are kind of the main cluster API resources that would be created for a given cluster. So that's the end of the demo now.
Okay. Very good, Peter. So thank you very much. Are we back to the audience for the Q&A, or do you have some kind of?
We have a few more.
Oh yeah, go ahead.
Yeah. So let me share this now. 1 second.
So I'm going to take over again.
Okay.
Yeah. So we're just going to go through the day 2 operations piece, Rainer, and cover certificate management and how it works. So Peter gave a very insightful view from the CLI, how to install it and troubleshoot it and all the various aspects of it and how it uses kubeadm and cluster API. But once it's up and running, one of the issues that we see regularly is around certificate management. So by default, kubeadm will generate all the certificates needed for the cluster to run. And kubeadm will place those certs in whatever directory is specified within your kubeadm's cluster configuration file. So there's 2 ways. You can use the --cert dir flag, or you can use the certificates dir field. TKG actually follows the default behavior and uses the certificates dir directory field, which points to etcd Kubernetes PKI. And PKI is a default folder for Kubernetes. It's a public key infrastructure, I think. So there's no auto rotation, happens during the upgrade of the control plane nodes. So all the certificates in there, you've certificates for the Kube API server, etcd, scheduler, controller manager, all components that need to interact with each other. And when you upgrade the control plane or you roll the control plane nodes, it regenerates the new certs for the next 12 months from your 10-year certificate authority that is auto-generated during the installation. This feature is designed for addressing the simplest use case. So if you perform Kubernetes version upgrades regularly, one every 12 months, then your cluster is automatically kept up to date with renewed certificates, and TKG inherits this behavior. Okay, so if you want to check the cert expiration, actually there's no API method to do it today, or there's no UI to facilitate such a request. So you have to SSH onto the control plane nodes, and Peter showed you how to do that earlier. And once you're in there, the kubeadm CLI is available by default. So you can run the kubeadm cert check expiration command, and you can see on the side there, it gives you your from the kube config file, it looks at your admin.conf, and then it looks at from the PKI folder, it looks at the API server, the client API server to etcd, API server to kubelet, etcd health check, etcd peer, etcd server from the PKI/etcd folder, and then the front end client and the scheduler.conf. So the 3 conf files, the admin conf, the control manager conf, and the scheduler conf, are from the kube config. And then down at the bottom, we have our certificate authorities, and these are 10 years. So you can see that there's, it goes from the time of installation, it's 10 years. So we have a CA for all the Kubernetes certs, and then we have an etcd CA and a front proxy CA that's more for extending the Kubernetes API. We won't go into that one. So you can see the certificates have 12 months, and then the CA is 10 years. Okay, so the command shows the expiration from the PKI folder for all the client certificates, and then the kubeadm or the .conf files referenced by kubeconfig. Kubeadm cannot manage certificates signed by an external CA. So if you want to give it your own CA, kubeadm can't manage that today. So you'd have to auto, or you'd have to regenerate all the certs yourself and then apply them to these to this folder if you wanted to maintain your own CA. The kubelet conf is not listed here because it's running on the worker nodes, of course, but that is not included because kubeadm configures a kubelet for automatic certificate renewal. So we don't have to worry about that. It's automatically taken care of. But if you want to check the expiration of your kubelet cert, you can use it doing the standard OpenSSL command, and that's the folder location of it, and it will give you back the dates. Okay. So in addition to that, we have scenarios where customers can't keep up with the release cycle of Kubernetes, right? Because it's very frequent. It was once every 9 months, and now I think it's one minor every 12 months. So effectively, if you have a cluster that's 2 years old, it becomes out of date very quickly. So you need to keep up to date with it, and there are various reasons why enterprise customers can't. They're running critical applications, they have change control windows, all that kind of thing. So it can be a case where they cannot upgrade the environment within the 12 months. But unfortunately for those customers, there's no alert mechanism. There's no API query that you can run to check. You have to actually manually SSH in and check. But we have a way of manually rotating the certs, and there's a VMware knowledge base article listed here that will show you all the manual steps that you need to do it. It's very manual effort. Wouldn't recommend it. But if you're familiar with cluster API and kubeadm, then you'll know that like you just need to roll the control plane nodes to renew the certs. And we have an object called like the kubeadm control plane object. We discussed it already earlier. Peter covered it and I covered it. This KCP object controls the control plane, and therefore it has a field in its spec file called rollout after. So if you add the field rollout after, and you can set a timestamp, which is an RFC timestamp of a period in the future. Once it reaches that period, it will trigger a rollout. It will trigger a rollout of the upgrade of the control plane node. So because of etcd n-1, it's normally 3 or 5 control plane nodes. Okay, so once you trigger a rollout, it will create a new control plane node with newer certs, and it will remove the old one, and it will go through the same process for each of the 3 control plane nodes. And effectively, you renew your certs for another 12 months with that process. And that's an example of the spec there. So underneath the replica, you can add rollout after, and that's an example of the timestamp that you would need to do when you kubectl edit the KCP object for your cluster, and then it will trigger the rollout. It doesn't cover worker nodes, because the worker nodes are managed by the machine deployment object. So what you can effectively do is you can actually patch the machine deployment object. And here is a kubectl command where we're going to patch an object, and we're going to merge within the spec template metadata annotations field. All we're going to do is add an extra date field in there with a number. No, we don't need it. It will never be used, but it's a way of making a change to the spec file of the object, so that triggers the rotation. Okay, so it's a manual way of adding an entry into the spec file that will trigger a rotation of the worker nodes for you. So what'll happen is you create a new worker node for the first one, gets new certs, a new kubelet cert, and the old one gets removed. And we'll do that for all the worker nodes in your cluster. So that's kind of an easier way from an operation perspective of doing it, rather than following the full knowledge base article. Okay, that's just some stuff that's handy for support engineers and customers that are maintaining these clusters to know. So now I'm going to hand you back to Peter. Peter's going to just cover crash diagnostics for a few minutes, and then we'll have time for Q&A.
Thank you, Mark.
Hey, everyone. So yeah, so what I'm going to do is just cover crash diagnostics, or Crashd as it's referred to, and essentially it's just a tool for gathering log bundles from our TKG clusters. So it's an open source project, as I say, and it's just used to gather infrastructure and cluster information from the TKG clusters. It uses a script and it just creates a tarball. And within that tarball, then the type of infrastructure information is the likes of the cloud init and the kubelet and containerd information that we touched on earlier. And then for at cluster level, it's the status of the different deployments, pods and services, and all logs for those pods then as well, within the Kubernetes and the Tanzu namespaces. So it's it doesn't gather information from any customer workloads. It's just purely from the core Kubernetes and the TKG ones. And it's widely used by the support team for analysis and troubleshooting of the clusters. So I'm going to do a quick demo here now, if we have time. Just give me 1 second. Okay, so I'm just going to, I have a cluster here. So let me just log on to it. So I just have a simple workload cluster here, and I have Crashd installed here. And when you're gathering the Crashd can be used to gather logs for any of your Bootstrap, your management or your workload cluster, and you configure this particular args file here with the different types of data. So, you know, you're looking at, so let me scroll up to the top. Yeah, so here we've specified that we're going to gather our diagnostics from the workload cluster. It's supported on the different types of IaaS then as well. We have a vSphere cluster here. This is just a local work directory where the data will be captured. It uses SSH to gather the infrastructure information. So we provide the SSH key, and then just the kube config then from the management cluster. So, and then we just specify the different the management cluster name. So what I can do here now is Crashd. I think actually. So this is the information we just run to gather the log information for that particular cluster. So just point it to the args file, and then it uses this diagnostic script then that kind of details what data it will gather then from the cluster. So this will just take
Oh.
30 seconds or so. I ran it in debug mode because I just kind of wanted to show you kind of the information that it is capturing. But it's, yeah, it is a bit much at the moment. But like if you kind of just look at kind of what it's doing here, you can see in the first half it's SSHing, and then it's just gathering the likes of the cloud in it.
Mhm.
And then down here, it's gathering the likes of the pod information. And in this particular case here, we can see it's the Entrea pod in the kube system namespace. So if we look at what it has done here now, so this is the tar ball that it would create, and then within this is the work directory that it gathered all the information in. So if we look in here now, so we can see that there's 3 directories here. So we can see that the first, if we look at the IP address of the 2 nodes, we can see that the directory name corresponds to each of the nodes in the cluster.
Mhm.
So we go into it then, just have a look. And then there we have the likes of our cloud init and our kubelet and containerd and the journal CTL. That's the sort of infrastructure level information. Then we'll be going to kube capture. We see it gathers the information from these particular namespaces, and then we can see it has just a JSON file with the details of the pods running in this namespace, and then a directory. Then we can see that if we just run this. It has for every pod running in the namespace, it has a corresponding directory. So say the likes of just the API server, go into the API server, and then it has just a kube API log, just standard kube API logs. So that's kind of it then, really. That's Crashd. I know we're short on time now, but if anyone has any questions or any of the topics that we covered, then we'd be more than happy to answer those anyway.